Thanks for joining. Sorry, it took a while. I have some setup to do here. So today, last session we talked briefly about testing, right? So how many of you attended the testing lab? Cool, yeah? The typical 3 ones, that's brilliant, yes, cool, yeah, should make it more. So one note on the lab, so we have a bit of a situation, I like that. So it's the labs reflect roughly the attendance rates to the lecture. In contrast to the lecture, our labs are really tedious to prepare, right? So if they put a lot of work into it, Elizabeth and Martin, and actually setting up the lab beforehand and so on. And we don't have quite the resonance we probably should have for those labs. And I don't want to discourage the ones that actually attending to stop doing so, but we decided for now that it makes more sense to actually have you guys being proactive, or not you as the ones being present here, but you ones there that may not be present here in the stream, for example, to actually proactively ask for labs if you want them, right? So it means they don't already prepare, they will just be there and help you with specific problems, but there will not be any specific lab sessions with of particular topics, at least for now, because it's just too much time expended on just preparing for very little return. So meaning the resonance is not particularly high. It was an experiment, and we'll see. We continue resuming that if we have the attendance or demand, but only upon negotiation. So I'll edit a new label into the issue tracker in the mobile GitLab, and I'll ask you if you want to have a lab or want to meet them in the first place to use that label. It's called lab appointments. That's right. So you can indicate your interest for the labs, and then they will show up and of course help you with your issue concerns on Thursday, usual time, but there will not be a default session if that's the expectation, right? And of course the room is at your disposal on Thursday between 10 and 12, I believe, because that's how it's scheduled. But that's the idea. So it's a bit on you, right? If you feel like we need support, then you should make an appointment or use that time frame to do so. I'll also, on another note, so Mariusz mentioned that very early in the course, at least I hope he did. Didn't check the stream for now, but the idea is we gave you very long and late deadlines. Who disagrees? Who knows the deadlines?
I don't know level of time, but I do know that it's like 2 weeks now until the first and for Lab 1 and 2.
Cool, yeah. Sweet. So there are deadlines, that's so good. So we're getting somewhere. So it's very uncommon to do that, right? You probably figured that out, right? In most other courses, they give you really hard and fast deadlines, right? And early, most likely. Some have passed already. So part of the reason we're doing this in this course is because, why do we give you late deadlines?
Time management.
That's right. What does that mean, roughly?
So that we have to schedule our time ourselves instead of starting the day before.
That's roughly the case, right? So if you start the day before, good luck. Plus, you will not get the support you probably need. So the idea is you learn how to time manage. And the reason is that we find it's actually a bit of cheating giving you deadlines, because we're actually managing your time, but that's not quite what we want to end up with, right? So this is an advanced second year or actually third year paper. Remember, it's a 3 in the beginning. And towards the bachelor, or in the bachelor itself, time management is kind of on you. Right? We ideally don't want to watch you. If you don't show up, we don't see your supervisor. Good luck. It can go well, but it can go really sideways as well, right? So there's a lot of ample examples for that. So we want to train that a bit up so that you guys actually take time into your own hands and say, well, actually, hang on, we have 4 assignments within in a cluster around 2 weeks or something like this. You probably need to invest time early and actually get it done, right? And of course, getting it done is important, but also think about support, right? There will not be opportunity to expect getting response or support on the last minute, certainly, but also assume that there will be a peak in responses and requests, so yours may just not be satisfied. So it's important that we encourage you to do it early, and I do it repeatedly now. Mariusz did it earlier, I'm pretty sure. But now is another point in time to actually indicate this. If you need support in the labs, indicate it using the mentioned label in the issue tracker, and then use the lab times for that one. But if no one shows up for the labs, then there is no demand. But I think there should be demand by now, else people haven't started looking at the labs yet. or the assignments yet, because they are some of them are a bit taxing, right? So
I have 4 bugs in lab 2. I need to make tests after I finish fixing those bugs.
perfect. See, there you go. So lab 2 is already good direction. So I would be happy if anyone was as far. So how far are people in general, feeling wise? Lab 2, how many?
Lab 2. I'm working on it.
Yep.
I'm almost done.
Cool. Lab 3.
I want to finish it. I want to work on it after I finish lab 2.
Yeah, sensible. Okay, cool. Lab 4. Okay.
Yeah, well.
It bottoms out a bit, right? So that's fine. Okay, lab 2, that's cool. So if you're on board, that's roughly where I want you to be. Just bear that in mind, right? So if you need support, pick your times wisely, or use the opportunities, because now there are basically ample opportunity in the upcoming weeks for those Thursdays. Use them. Cool. Enough bashing. Yeah, I use the labeling issue checker. Generally, we have an eye on it, but it would be good to have this label, so it's very easy for Elizabeth and Martin to spot that, right? So it us, of course, as well. Cool. Right. So last session we talked about
Testing.
Oh God, is that a guess or is that?
No, we did talk about the different testing.
That's good. Okay, so that's with high certainty. Okay, probability of 1. We talk about testing. What kind of testing do we talk about?
White box testing, black box
Yeah.
testing, integration testing.
Cool. All that stuff you know already, right? Cool. Yeah.
Unit testing.
Unit testing. Cool. What's the tool for unit testing?
JUnit.
Cool. We briefly had a look at it, right? Really briefly, right? So and that was also discussed in the last lab. So I'm not sure if any material is linked from the lab, but anyway, so JUnit is actually straightforward, right? So yeah, basically set up some methods to test certain functionality in your code, and you have some sort of before and after statements that are actually executed to set up the test environment, to tear it down afterwards. And all is done in Java using annotations, right? The things with the adds in the beginning. Cool. Which you're quite comfortable with. So that's basically a baseline testing we expect, right? 70 to 80% of all tests are unit tests. And for the assignments, ideally, for the project for certain, we'd expect you to actually use tests, right? Specifically because it's built into the framework, into Android Studio. And why not exploit it? And it's actually really cheap to use it, but it may require you rewriting your code for testability, of course, right? Decouple, for example, logic from UI, things like that, right? So it's usually a bit of a entanglement there. So having covered that, you kind of have the baseline of what you need to know in order to use it, for example, in a practical session. What I'm talking about today is to go beyond slightly and look at some specific cases or features regarding testing. Yes, I show you some demos and some examples, of course, but it's not necessarily stuff you may use. You may use that, get bonus points for it in your projects or so on. But it's more like to raise awareness of what the different concepts are and how you can use them possibly in more advanced projects, right? But also talk about concepts you may not have heard about at all. So, okay, last session, white box, black box testing. We characterized it because of the different perspectives, right? So, what's the difference there, white box and black box testing? Slide, hint, okay. I'm just testing your eyesight, I'm actually not testing your memory. Right, cool. So intuitions, yeah?
Well, in
Organize
white
it.
box testing, you can see the source code. In black box testing, it's sort of just in, out.
Yeah. What's the purpose? Why don't we always do the white box testing, look at the source code? So it's the perfect opportunity to get insight, right?
Just then you already know how things are supposed to work and such, maybe. You're supposed to on it from the outside, like maybe a user,
Right.
and they will use it and they don't know how it's supposed to be used. So
Yeah.
if you have inside knowledge all the time, then you will not interact with things in the same way as if you're completely clueless.
Cool. Perfect. Exactly. Right. So you have a bit more of like a, you don't know what's inside. You're trying to interact with this. You're using some strategies, right, to exploit the parameter space a bit. What was the concept we called there, or I briefly talked about there? How do we cover our grounds? What kind of testing do we use? When we need to pick parameter values, for example.
Boundary values?
We're working on boundary values, right? So it's formally called equivalence partitioning, right? So that's the idea that you look for the boundary values and test each of the partitions surrounding it. Therefore, you can probabilistically assume that you covered your you know, have the entire ground basically, right? So, and then in contrasting to black box testing, we had white box testing. What are metrics in white box testing that we're using for assessing comprehensive view again?
Code coverage.
Code coverage, right? So it's all about code coverage, because since we know the code, we can assess the coverage, right? Or the tools can anyway, right? Cool. So key concepts. Yeah, that's roughly what you want to know about this. There were two terms to the V. What were those terms, and where do they go here in this figure? So,
verification, validation.
cool. Which one goes where?
Oh, that's a 50-50 chance.
That's a 50-50 chance. That's right. That's right. By exclusion principle, 50% chance. So who is somewhat confident or wants to take a guess, take the risk? Before you sign up, give me your name first, so I can actually give you bonus marks or discount your marks in the end. No, I'm just kidding. Please.
Validation for white and validation for black.
Yeah, you check the slides. Very clever. No?
I have no success verification. Are we building the project?
That's right.
And
That's right.
based on that,
Cool. That's right. Yeah. So can you explain what does it mean?
well, verification, there we are checking if what we have done right, and then you need to have seen inside of the project to actually know it.
Yeah.
And because of that, that's whiteboxing, because you can see the code and you know what you actually have.
Yeah.
While are we building the right product in validation? That's more black, because you don't care about what's inside or how it works or anything like that. All you care is this the right thing? Is that the thing we're supposed to have built in the first place? And does it do what it's supposed to do?
Yeah. Entirely correct. Exactly like this, right? So it's really like customer focus. Does the thing solve a real world problem it was meant to be built for? And that's validation. The verification thing is really, okay, did I build against the specs that I got, right? As a dev, right? I got the specs, requirements, satisfied them, done, right? My job is done. But it doesn't tell me much whether it actually works in real world, because the specs may be off, or I may not have covered certain use cases and things like this. So spot on, cool, yeah? So remember those terms, validation, verification. They are not only applied to testing, they are also applied to scientific methodologies, right? So if you're doing systematic evaluations, it's also about verification versus validation. Exactly the same characteristics. Inwards facing is verification, outwards facing is validation. Cool. All right, cool, thanks. So we briefly talk about the hierarchy in a way, right? The unit test is pretty much everything in Android. And then we have integration tests, to tie different components together, databases and other frameworks, for example. And then the pinnacle is UI tests, where we actually have the system interact via the UI and hope that everything works out, right? So that's probably it's kind of a functional test that you can perform there. So UI testing, is it more like a black box or white box thing? In principle.
I would say black box, but
Yeah, okay, you?
I'd also say black boxes, because you see the GUI and what is outputted, but you don't see how that is outputted.
Yeah, right? So, I mean, of course, you can have knowledge about the structure of the code, but fundamentally you don't, right? So, because you press blunt buttons, and you abstract it away from the implementation because you expect a certain output, it kind of forces you onto the outside perspective, right? So if you develop a calculator, you don't care about the internal implementation. You want to look, does the result that I'm, expecting is actually the result that I get, right? So that's kind of a nice way of forcing you to that level. Yeah, cool. So in Android, we have two ways of testing things. That's specific to the environment and tech, of course. One of them is actually doing local unit tests. They basically run in Java, in the JVM, because Android, of course, builds on the JVM or remodels the API of the JVM in the first place. It's in fact, a new implementation. But it can, of course, then use the native local JVM, for example, to do simple unit tests, right? As we have seen last time. So quite straightforward. In contrast to this, we have also instrumentation tests, and those are the ones that actually require the Android API, so specific functionality that is built into Android generally. It often requires you to actually boot up an emulator, right? So to actually run the tests in the emulator, that would be instrumentation test. So those are the two kind of types of tests. Last time we looked at unit tests. This time I'm looking more at instrumentation tests. So we'll have an overview of this one in this session more explicitly. And specific cases that we are looking at is to mocking UI tests and behavior-driven testing, right? So, so it's kind of all across the board. It's just, you know, broadening our horizon a bit. We conceptually talked about some of those aspects, but today we kind of want to put a bit more of ideas to it of how we can actually approach it, right? Or how you can approach it if you want to. So it makes for interesting exercises, and it's sometimes a bit challenging to get it going. Unit testing is straightforward. Those ones can be a bit more daunting. So mocking, what's that? Random pick. How do I throw dice? Okay.
When we kind of said it last lecture, and for example, have a mock server, so you don't actually connect to the internet, to have like an object that kind of mocks the interaction.
Yeah. Right. Yeah. Cool. That's right. So when is it fundamentally used? Mocking.
When you haven't implemented everything yet, and you just need the object to be there because you want to interact with it, you don't have it.
Yeah. Yeah. Any addition?
Or when you're trying to see if what you built is stable and secure, and it's connected to something where security is important. If you just go in the implementation and you just take it out of the internet immediately and connect it to everything, and then you find you have a security hole there, then that could be horrible. While if you identify the security issue while just mocking it, then that should be fine.
Right.
Does that kind of go into like pen testing almost? Like
penetration testing, yeah, that's but that's usually more working on the live system in a way, right? So I mean, here it can, that's not specific because it's not necessarily pen testing is also more like a reliability robustness metric, right? Here it's really more, could be more subtle, like a bug in your code, right? So the way I understand it, or the way it probably should be understood, is in a way that you isolate certain components of the system, right? For example, you move the backend entirely, only care about the front end or whatever else, whatever you want to expose, and you want to test that thoroughly before you actually use it. Or in the case of regression testing in a wider sense, you're doing a change, suddenly things fall apart. You want to figure out what actually breaks and where, right? So you can, if you separate backend and front end, respectively, then it's relatively easy to test that, right? Because you can test front end separately using a mock, and you can use the backend separately using what concept? What's the opposite of a mock?
Driver.
Driver, right? So what's the driver doing?
You take a web driver, for example, for testing the web. You can fetch the HTML and interact with it programmatically.
Yeah. So think about like a robot, right? So basically it interacts by injecting code and expecting outcome and assessing that one, for example, right? So it's kind of the opposite. It invokes your stuff, whereas the mock is something you invoke, right? So may expect certain output. So it's kind of the complement in a way. Cool. So that's a good summary of it. That's the slide I showed last time. So basically, if you want to test, for example, unit A sitting on top here in the structure, and you have unit B, C, and so on, you can mock all those ones basically, right? So then the system will just invoke the mock structure, and you know that it will guarantee return certain values when you expect certain input. It's not the full implementation. It's just geared towards usually towards very specific tests, right? If it's get value 2 as an input, spit value 4 out or whatever. No logic behind it. It's a blind response, right? So it's very the logic is usually very simplistic there, and it only works often with very specific tests. So if you change the test, you most likely need to amend the mock as well. Right? So that's the thing there. So and of course you can do that throughout multiple layers of the systems. Right? So in terms of terminology, there's a lot of bit of confusion. Sometimes there's the term mock, stub, dummy, things like that. So it's also worthwhile just to disambiguate them to some extent. Or at least the understanding that we share here, that's widely, that's generally the approach taken. So if you have, for example, dummy, that is usually an object that you pass around, right, between your code components or within your functions or methods or whatever else. And you just want to have something you can pass around to assess whether it has been passed around or not. But in itself, it doesn't have much functionality or value in itself. You just need to put a parameter into a function or method for it to assess whether it works. And then you can assess if it actually has been passed through. That's the dummy you use there, right? Fake object is a bit richer. So fake object goes further in the sense that it usually implements a subset of the original complete functionality, right? It can do very simplistic things. For example, print the inner state, right? Or it can change one state variable of the inside and read the rest of it or whatever else. Whereas in the fully fleshed object, it's much richer with a lot more properties that go beyond the actual test, right? So in this case, a fake object would be subsetted to an extent that it just fits the test requirements, but not much more, right? So it's always about simplifying the implementation. Here it's about the object that you pass around if you think object orientation. If you think about architecture, so that's where stub and mock come in. And here it's kind of similar, that we have a mock, which is basically just an interface like the API you interact with, on which you can augment with certain expectations and response values that are provided, usually bluntly and blindly, whereas the stub is a bit richer. So where you actually have some sort of partial implementation, similar to the fake, that you actually have some functionality that actually works, but the rest not. So assume, for example, some methods are implemented, some are not. Yeah. So you can actually, it's kind of an intermediate state where you don't really have a clear separation of layers anymore, but you actually want to model meaningful interaction to some extent, perhaps a simple calculation that you want to perform. If you, for example, have a hypothetically a server-side calculator, you implement, for example, the addition functionality but not the rest. Yeah, that would be a kind of stub kind of approach. Often if you use frameworks that are cross-platform, right, for interaction, for example, messaging frameworks like ZeroMQ, or in Android, the bound services, we talked briefly about the AIDL, so the Android, interface definition language, which basically works across different languages. They generate usually a stub, so a partial implementation in the corresponding programming language, be it C++ or Java, whatever else, right? They give you a working baseline implementation that you, of course, need to fix and augment. So it's not just a mock, it's not just emulating the interface, but it's actually giving you the actual implementation starting point, so you actually have actual methods, not just the interface, that you actually need to implement and write your code in, right? So that would be kind of usually stubbing stubbing facilities. So to make your life as a developer somewhat easier, right? So so some of those concepts are not only used in the concept of testing, that's probably the most prominent use, but they're also relevant in other areas. So if you come across it, don't be surprised there. Okay. So generally this kind of testing, mocking and so on, is around testing in isolation, right? So how do we do it? Well, we use some sort of mocking framework that mock objects. They mimic behavior of objects in a real sense, and the dependencies are modeled here, right? So if you have, similar to the previous point, actually quite similar to the previous diagram, but it visualizes a bit differently. You basically, if you have the dependency graph here, as shown on the left figure, and you just want to model the interaction of A with the rest of the system, you just prune the tree basically and just mock component B and C to see if actually the interaction works, if A does the right thing. Cool. All right, purposes for mock objects. If some parts are not implemented yet, we talked about this. Yeah, the second one is quite interesting. Sometimes you kind of don't have a choice. If you have a large system, for example, let's say a search engine that has considerable amount of data for indexing or for big data sources, for example, and you don't really want to expose those to your functionality yet, then of course mocking may make sense if you can't replicate a test environment, right? So if you actually deal with a real search engine, you don't have the capacity to have another copy of that thing running somewhere for testing, then it's probably a sensible choice to start mocking, right? Because it becomes too expensive to replicate. So that's a possible pathway as well. Or if you're in a company, don't have the luxury of actually replicating even your business environment because it's so reasonably complex, right? Then it's a good point in time to think about mocking, right? And of course, isolation by definition is avoiding side effects. So for example, if you know that if you're invoking a certain business process, for example, you are setting in motion a lot of subsequent procedures and things like this, and you don't want this functionality to spill over. For example, you're placing an order in your in your business information system, ERP system if you like, and if you know about ERP systems, they are really integrated. They consider everything from logistics, materials management to accounting, and so on, right? So it would mean that as soon as you place an order, you basically actually withdraw the item from stock. You deliver to certain or prepare delivery to the client. You have an entry in accounting and so on. So suddenly everything kind of is reflected in the entire system. If you want to avoid this, it's also a good point in time for actually doing stubbing, because you don't quite know if your ordering component doesn't work yet, and you don't want to test the entire business process yet, but only just, can I press the button and there's something happening. Yeah? So that's also one way of, one reason for mocking, of course. Cool. So, so much talk. Which libraries do we use? Well, in Java, actually, and in Android, in extension, kind of there's the library as Mockito, right? So there's various ones. Another one is called EasyMock, for example, has been around for some time. But I think Mockito is the one that is referred to most often and most often integrated with other functionality that built on top of it. Similar to JUnit, that is kind of the implied library, and most libraries then build on it. So similarly here, Mockito builds on unit tests. So it builds fundamentally on JUnit, but you just use that as a DSL for writing log. What's the DSL? What could DSL stand for? Does anyone?
Defined structured language or something?
Sorry? Yeah?
It's like defined structured language or something?
Nearly, yeah. Well, so it's not digital subscriber line, right? So not the internet DSL thing, but it's actually a domain-specific language. So that's the idea. So you're devising a language that is applicable to a particular domain, but very writable in that context. We'll see two other examples, or at least one other example of that one later on, and you get an impression once we work with this. So DSL, domain-specific language. So it's integrated with unit tests, and it can, of course, be combined with more advanced features, because it's simply just a specification of what environmental or what environment is under which context, meaning which environmental state happens what. So when I do, for example, something, I call a method with certain parameters, then I expect a certain result. That's basically what you're modeling, right? So that lends itself quite well to simple representations in a domain-specific language. For example, so we have a class here, my class, that's actually the implementation, right? But we say, hey, mock this thing, right? So actually create a mock of my class. Yeah? So basically look at the interface of that class, and then you kind of need to specify certain behavior. Right, so if we instantiate the mock here, so we just have the interface, implementation is gone, right? Then we need to say, well, here's the specification, that's Mockito. When we have a call on test get unique ID, so checking the interface, method get unique ID, whenever you get a call on this one, then return 43. So from then on, every time you call test get unique ID on the mock, you'll always get a 43. Yeah, so that's it. That's how you specify behavior. You can extend this, of course, and say, hey, when test get unique, no, then you probably need to get another method of this object, of course, of this mock. You say, when test get 2 IDs or whatever else, then return, right? So something else. You're basically a set of 2 IDs or whatever else, right? So you can implement an arbitrary number of those kind of principal rules as long as they satisfy the interface, right? The interface of that class, right? Meaning all the public methods, basically. Does it make sense? Quite straightforward? Yeah. Take a class, make a mock out of it, and then ascribe behavior to the interface without caring about the actual implementation. The mock takes care, the mock framework takes care of that. So every time now there's a call on this method, this one will be returned, right? So then you do the tests. And the assert equals, for example, that's, where's the assert equals coming from? That's JUnit, right? So it's not Mockito anymore. So Mockito's only that bit here. The actual test itself is written in JUnit, technically, right? So it basically just, well, test get unique ID. So that's the expected, that's the expected value. That's the actual value, right? So we are compared, assert equals, and it figures out, yes, it's probably true, and then it probably works out, right? So that's the rough principle of a mock. It can be quite a bit more complex than that, but that's the idea. And if you look at why I'm explicit about the DSL, if you look at the description, you find it's actually quite legible, right? When I do that, then get that, right? So that's kind of the spirit, that it can be written in a nearly, well, you can nearly go as far, I would say, to say it can be written by the user, right, as opposed to the implementer, right? So when I call something, then I expect the following. So it's nearly human readable to some extent, right? So of course there are those ugly dots and parentheses, Java-esque nature, But you can abstract this away. So that's typical for domain-specific languages, that you chain statements to express it in a sentence-like format, which is intuitively understandable. Right? Slightly more complex one. So, for example, if you mock something from the class library in Java, in general, from the Java API, a comparable class, comparable, and, well, you know, you basically say, well, ascribe to the comparable instance, which is now a mock, say, well, every time you compare this thing to the string Mockito, return 1. Every time you compare it to something else, return 2. Right? So that's another alternative you can basically do. And then again, you have the simple JUnit tests. Well, you expect the value 1, and you know what is coming back. Well, supposedly value 1 if the mocking framework is doing what's supposed to do. Quite straightforward. No questions? All questions? Worries? No? Who dealt with this before? Or in a different world, might mean not in Android or Java world. Perhaps you saw it in different programming languages or used it elsewhere. No? Okay. But it's worthwhile to know, right? So if you have this situation where you have this bloody component, you just want to have it spit out a value and don't want to hack that around, just use a mocking framework. It's as simple as that, right? So it's really, this is Mockito, the rest is JUnit as it was before. So no challenge there. Of course, can be a bit more complicated, and if you want, you build it up a bit. You can, for example, test databases. So that's an interesting one. So here you have a mock of my database. You have some sort of supposedly one implementation. This is just every time you're dealing with Mockito. Mockito, you kind of instantiate Mockito in that very well. You say what's the rule set for Mockito, and you instantiate the Mockito JUnit rule set. So that's kind of something you can blindly copy, pretty much for any Mockito kind of setup. But here the interesting bit comes. So we have an annotated test, which is the method test query, the class to test is basically instantiated with this mock object here, and what you basically say here as well, it does the Boolean check as to whether performs a query and basically checks the result and expects a true, right? So it's not explicitly specified here, but it expects a true on the call of a query. What is more interesting, and so that doesn't really matter, it just checks that it actually has done the query. The interesting bit comes here, verify database mock query from T. So what does that mean? Well, it goes the other way around. So instead of assessing from a user side what the mock has returned, it actually asks the mock what the user has done. Right? So the question is here, verify on the database mock that this query was performed. If it's not, so verify in this case is a keyword that's from Mockito. Right? So this is not JUnit anymore, this is Mockito. They say, has this happened, right? If not, give me an error. Because it could equally mean that your application actually is flawed and actually didn't do the invocation, right? That you expected, right? So that's actually quite neat. And you can also be richer, more explicit about it, and for example, indicate the number of invocations you expect. So it becomes very complex fairly quickly. Hang on, see if I have a... So unfortunately, I didn't have enough time to write all the examples, so I borrowed some examples from that. I'll be transparent about it, so the links are all available. So this one is, for example, a web service test activity. So quite straightforward idea. You basically have a web service with a login interface. Let's see if I can bring this up. This thing, perhaps I brought it up already. Give me a sec. No, that's not that one. Sorry, it may take a while. Machine is a bit challenged when it's about when it's streaming and doing other stuff at the same time. It has worked, some say. So basically the idea is here, this is kind of a web service implementation, very simple one, where the idea is that we want to test the user's ability to log into the system. Oh, there's actually no proper UI attached to it right now. Okay, doesn't matter. So we have a login activity, and we have a login interface, for example, that could be implemented and needs to return failure and success of particular logins. And of course, we have a user. A user is injected with a web service and can perform certain tasks on the login interface. So if you pass the login interface, it will check whether the network is offline, and if the network is offline, it will call the callback that the login has failed, or otherwise it will indicate that it's actually successful, right? So down here. Cool. Similar to for logout, it will just blindly call the logout on the web services, right? So basically, this is modeling the interaction with the web service. And if you want to send messages to a web service, then there is this one here, send message, string message. It will just invoke the web service method, send messages. Quite straightforward, simple idea. So let's look at the web service. Well, if you look at the web service, all the methods are actually not implemented, right? So all of them throw the runtime exception not implemented. So if you were to run this thing actually on the web service, nothing would happen. Yeah. So in this case, the idea here was that the user models, or the developer rather, models the front end, right? So user perspective, what the user side can do, but couldn't be bothered to implement the web service itself. And here's where this whole Mockito idea comes into play, right? So if we, for example, so if we, for example, verify interaction order. So if it's, for example, very relevant to test whether a mock upon instantiation, upon login and so on, has been called in the right order, you can easily do that. So in this case, we instantiate the user with the mock web service reference, right? On the user, we call the login and we call the logout. So what do you do afterwards? Well, you inquire with the mock web service with respect, inquire of the order of invocations, right? You have two invocations in the web service, supposedly, the login and logout. Recall when we looked at the user, what does it do for login and logout? Well, in both cases, it takes a reference to the web service and calls the respective login and logout methods, right? So that was the idea. Let me get back. What we do here is basically the following. Well, just, okay, now after having recorded the order of invocations on the web service mock, verify that the mock service has first been called with login, and you tolerate any input. You actually don't care about what the user put in. It could have been null or and in this case any integer, right? So any string or any implementation of the response class. So basically, you would tolerate pretty much any input as long as login has been called, right? And afterwards, you would expect logout to be called. If they will be called in the inverse order, in the wrong order, you would get the whole test would break, basically. That's the fundamental idea here. You can just run this test, see how it actually works in the first place. But it's fundamentally, it requires instrumentation to some extent. Yeah, it does, because it has uses activities and stuff like that. But fundamentally, it will just here run the different tests. Let's just see if they all work out, because there's quite a number of them. So it's basically just a series of JUnit tests, and they all work, basically. So now we have here the order of, what is it, verify interaction order. So if we were to change here the interaction order and not change it in the user, of course, hopefully the thing will actually fail. Let's run this again. We can run isolated tests, of course, as well in JUnit by clicking on them, right? So it's quite straightforward. So don't hesitate having large number of tests because you can still run them individually. So let's see what it returns. Oh, damn. It actually says successful. That's not good. In order. That is not good. Why does that successfully?
Was it the right test?
That's a good, very question. Verify. Oh, that's right. It's the wrong test. Thank you. Thank you. That's right. Thank you. That's something I should have. So, right. Thank you. So that's very, the output is quite explicit usually. So it says something, right here. Verification in order failure, right? Wanted but not invoked. So it wanted the invocation of login. Wanted but not invoked. So it expected the invocation of login. And that's a bit misleading here, right? Wanted anywhere after following interaction, right? So actually wanted before the following interaction, but anyway. So, but it's somewhat, it's nearly explicit enough about the actual invocation. Usually, it's something like wanted but not invoked, or invoked but not supposedly invoked. The other statement is also quite helpful. Is actually to assess the. Bring that back in order. See for another nice example that that's not what I want. So hang on. Yeah, this is a nice one here. The interaction times, of course. So in addition to assessing the order, which is one way, you can also assess frequency, right? So for example, we have a very simple interaction. User logging out, right? Okay, hang on. What should have happened here? So not only do we expect that the mock web server, of course, expects logout to be called. Cool, that makes sense. It also is explicit about that it should only be called once. Right? What happens if your process repeatedly calls logout, right? So whatever else. Firstly, inefficient. Secondly, it may have unwanted side effects. So you can constrain that as well. And there's various other ways of expressing it, right? You could say at least once, for example, if you tolerate more than one calls to log out, right? So, or for example, you only want the invocation on logout. So if, for example, you have the mock web service and there was a call to log in to get unique ID or whatever else and logout, that would violate this rule because only logout means this mock in this test is only to be called once with this particular method, right? So, or if it's never to be called. For example, here the example is that login should never be called, right? Of course, right? Because it's only testing the logout functionality. So that's the typical kind of use cases you basically you have for Mockito. So it's kind of neatly integrated. And the other thing that I just wanted to show you is that you, of course, can go down a bit and be more refined. If you want to, for example, check that login has been called. So next example, verify interaction parameters. We know that this test worked. That was the one that I erroneously ran just before. You call user login. Then you can verify not only that login was, of course, called with any possible valid argument, but also whether it actually was called with specific arguments, right? Login equals user ID, and the second parameter equals password, and so on. Or you can and you can do inversion tests. So, for example, you negate and say it should not be 0, sorry, and it should not be 1, 2, 3, 4, 5, 7, 8 for password, for example, and things like that. So you can do quite a bit of stuff. Should be greater than, less or equals than, or starts with, or contains, and so on. You have all the string matching functionality at hand that you would kind of expect and want. So you can be quite complex about your checks. And note here, you can all apply them to one single call, right? So they all refer to this one single invocation. This is the most generic one, and those are more refined, right, to test whether invocations have happened. And you can, of course, extend it by saying, well, I only wanted one invocation as well, right? So it's one of the key things that you could do as well. So that's actually a really nice facility that you mock objects and then inquire the objects in how far, what interaction has happened to them, right? As opposed to just you interacting with them. Cool. But I think that should give you some intuition of how it works. The ordering, verified. Is there anything else I wanted to show you? I don't think. Right. So it's another one here. Yeah. So you can also do slightly different tests. So here's an example for, again, invoking this web service, right? Calling a login. And then on the web service, you actually want to verify complex objects, right? In this case, you have the call, whether a call to log in has occurred with any integer as parameter, any string as second parameter, and then this thing here is the end, response argument capture. What the heck is that? Well, this is basically a dummy that just gets the, capture, they call it, that basically captures any value that is inputted there, so you can do post-processing, right? So after capturing this input, you actually extract, okay, response argument capture, what did you actually get, right? What has been inputted here? And then you can actually explore. For example, if that's a callback, in this case it is, you can actually assess whether response on request completed has been called, for example, right? So you can have more complex objects that can be captured and then post-processed afterwards. So it's a quite nice way as well. The argument capture. Basically, it just captures whatever has been passed into the mock service and allows you then to do operations on this one. Yeah, cool. All right, that's some of the things. Of course, if you look at the website of Mockito at mockito.org, there's a abundance of more functionality that you can do. And it, of course, it's not only extended to Android. If you are in the situation of writing a Java project and so on, same, it applies there as well, right? It's not specific to Android at all. You see how it interlinks with JUnit functionality, right? So you just inject it somewhere in between, but fundamentally the tests remain JUnit tests, right? We're still on unit test level, but it allows you at least to mock external components. Cool. All right. I think you deserve a break, I suspect. Otherwise, I lose you. So I give you until 15 past, that is 9 minutes. And then we'll continue and we'll look into GUI testing to some extent.